Hi guys, Ngangaro here, back with another video. Welcome to my YouTube channel where we always talk about everything data related. So today we're going to talk about machine learning algorithms. I'm going to explain a little bit about machine learning algorithms, which are things that people have asked about. And it will be brief explanations. If you want deep explanations, you just have to put in the work and try to find out how they all work. But I'll just give you a framework and a brief explanation. Machine learning algorithms, it's divided into two basic parts. There are some that can divide into three, but the most you can divide them into two, into supervised and unsupervised learning. Supervised learning takes input with labeled outputs and maps them out to predict an output based on the input. For example, you can have age and shoe size, and they're pre-filled, where you have collected the data and you have the age of people and their shoe sizes, and then you try to predict the shoe size of a person based on the age, or the shoe size of the age of a person based on the shoe size, and that is supervised learning. Another example, you can say you can have temperature and maybe eye color, and then there is the output is either the person is sick or healthy, and you can have the temperature and the eye color to determine if the person is sick or healthy from a pre-collected data. Then after that, you can try to predict if a person is sick or healthy based on the temperature and the eye color that you feed into this algorithm. And this is supervised learning, since we have labeled outputs from the inputs that we have. In supervised learning, we have two types, which is regression and classification. Regression just checks on the relationship or causality between two data points, and the output is continuous, while the classification, the output is discrete. Like for the example that I've given you, the age and the shoe size, that is a regression problem, while the problem where you can check temperature and eye color to determine if a person is sick or healthy, it has discrete outputs, it's a classification problem. The common algorithms that are used in the regression model are linear regression, which is just a line of best fit with basis to the regression line. This is the basic regression that people learn in school, where you have the two variables, the input and the output, mapped out, and a regression line is fitted into it, and trying to understand whether a predetermined or a predictive model can be created from this by adding a certain point into this and looking if where it lies on this regression line. The other part is a decision tree. The decision tree can work in various ways. You can have probably a decision tree, an animal decision tree, where there is the animal, if it's feathered or it's unfeathered. If it's feathered, it's a bird. If it's unfeathered, it's either an amphibian or a mammal, etc., etc. And this is a decision tree, and the more the nodes you have in a decision tree, the more accurate the data is, because if you have feathered and unfeathered, and then on the feathered you have birds, but rather than having birds directly, you can have on the feathered side, you can say flies and does not fly, and then you can have unflying birds and flying birds, etc., etc. The more the nodes you add on this specific decision tree, the more accurate the algorithm will be. Random forest is an ensemble learning technique that builds on the decision tree and involves creating multiple decision trees. The other thing that we have is neural networks, and these neural networks are a series of algorithms that endeavors to recognize underlying relationship in a set of data through a process that mimics the way the brain operates. The neural network involves an input and a lot of nodes with interlocking relationships that try to predict an output, and that's how the neural network of the brain works. You can have a better search at that, but that is also a form of a regression analysis or regression algorithm in machine learning. The other thing we have is classification. In classification, the output is discrete: sick or healthy, happy or sad, etc., etc. The common algorithms used here are logistic regression, and logistic regression, just like the linear regression, is just like the linear regression, but in this now it's used to model the probability of a finite number of outcomes. The finite number of outcomes being either outcome A or outcome B, outcome sick or outcome healthy. There's also support vector machine. The support vector machine helps to find a hyperlane of an object in a dimensional space that can distinctly classify the data points. Having these distinctly classified data points and then using the hyperlane of an object in a dimensional space to try and determine this if it lies on which distinct classification data point is also a form of classification model called the support vector. You can have a more look at that, and it's done using scikit-learn in Python. There's also the naive Bayes, which is a probabilistic model and is used for classification. Sorry, the decision tree, random forest, and the neural networks can be used either as a regression model or a classification model depending on which outcome you're trying to predict. Now let's move on to the unsupervised learning. In unsupervised learning, we're trying to draw an output or an inference for an input without labeled outcomes. So we have an input and the outcomes are not labeled. Okay? So if you're trying to get an input from unlabeled outcomes, probably you've just collected data and you're trying to get a specific information or draw an inference from this data that is not labeled. In this, we use several methods like clustering and dimensionality reduction. Clustering is basically just grouping of data points. You can take a lot of customers and try and group them into loyal customers and neutral customers without having those labels inputted into the data itself. In the clustering techniques that are used are usually k-mean, hierarchical, mean shift, density based. All these different methods just try to produce the same results, which is just clustering this data as effectively or as accurately as possible. Dimensionality reduction is a process of reducing the number of features. It can be extracting extra features or reducing the number of features. The common methods that are used here is component analysis, and a lot is involved in this. Most of the time we don't use this type of algorithms, but you have to know what they mean. So as I've said, dimensionality reduction is just a process of reducing the number of features. You can be eliminating the features or extracting features. So, and with that, we have understood what we were trying to talk about, machine learning algorithms. You can go in deeper according to which one you want to understand a little bit more. It was a lot of fun making this video, and remember, in all these algorithms, there's so many things that are involved, not just the basic things I've talked about, as you can see from the machine learning videos that I've created, the live coding ones. We've used random forest, we've used linear regression, we've used all these types of algorithms. You can just go and check. Thank you very much for watching. Hope this was informative. Throw in a like, subscribe, tell a friend to tell a friend. Let's learn data and become more data literate. Thank you very much for your time. Have a great day.